This week we'll focus on dosage calculations, concentrations, and percent strengths. In order to be able to calculate medication doses, it is important to be able to understand the pharmacy vocabulary, especially when dealing with pediatric patients. Pediatric dosing is generally used for anyone under the age of 12 years old. At age 12, with normal size and weight, adult dosing is assumed. So there's 3 rules for pediatric dosing: Clark's rule, Freed's rule, and Young's rule. Clark's rule follows this calculation up here. At the top, child's weight in pounds over 150 pounds times the adult dose equals the child's dose. This pediatric formula is one of the most common pediatric formulas. For example, a 10-year-old 68-pound child is to receive carbamazepine for seizure disorder. The usual adult dose is 300 milligrams. So we plug in these numbers into the calculation for Clark's rule. The child's weight is 68 pounds over 150 pounds times the adult dose, which we have here, is 300 milligrams. And we got 136 milligrams for the child's dose. Freed's rule takes the child's age in months divided by 150 times the adult dose, and you get the infant's dose. This formula is rarely used and is limited to patients under 2 years of age. For example, a physician orders amoxicillin for a 6-month-old infant. Usual adult dose is 500 milligrams. So we plug in these numbers into the formula for Freed's rule. The age in months is 6 months, and the adult dose is 500 milligrams. So you write 6 months over 150 times 500 milligrams, and that gives you 20 milligrams. Young rule takes the age in years divided by age in years plus the number 12 times the adult dose, and you get the child's dose. This pediatric formula is seen more frequently than Freed's rule and may be used for children's ages 1 to 12 years. For example, a physician orders amoxicillin for a 5-year-old child. The usual adult dose is 500 milligrams. So we plug in these numbers into our formula for Young's rule. 5 years of age is the child's age in years, and the adult dose is 500 milligrams. So when we write out the problem, we're going to write 5 years at the top, and at the bottom 5 plus 12. And when you go to solve it, you're going to add up what you have in the bottom first, which is 5 plus 12 is what? 17, right? Over 5 years times 500 milligrams. So then our next step would be 5 years divided by 17. You write down your answer for that times 500 milligrams, and that should give you 147 milligrams. So there are other ways that doctors might order medication for pediatric adult patients. For example, they may order it as a single dose based on the patient's weight in kilograms. So for example, a dose of 4 milligrams per kilogram daily of Plaquenil can be recommended for certain children suffering from lupus. What would be the appropriate dosage for a patient weighing 47 kilograms? So our first step would be to, if the patient's weight is not given in kilograms, to change a patient's weight to kilograms. So it's already given in kilograms. That's fine. Next, multiply the weight in kilograms by the amount ordered per kilogram. So we have 47 kilograms, that's the patient's weight, multiplied by the amount ordered, 4 milligram per kilogram, right? And we're able to cancel out kilograms. 47 times 4 gives you what? 188 milligrams. Remember to keep your units. So this is the appropriate dosage for a patient weighing 47 kilograms. Another way a doctor might order medication for a pediatric patient is in a daily total to be divided in equal doses based strictly on the patient's weight in kilograms. So for example, a child weighing 76 pounds is prescribed the antibiotic cefaclor. It is recommended for children to receive 20 milligrams per kilogram a day in divided doses every 8 hours. How many milligrams should the child take per dose? So the first thing we're going to do is change the child's weight to kilograms by dividing by 2.2. And why are we dividing by 2.2? Because 2.2 pounds equals 1 kilogram, right? So we're going to do 76 pounds, 2.2 pounds, 1 kilogram. So this is how we convert from pounds to kilograms. So we do 76 divided by 2.2, and you get 34.54 kilograms, right? And now the next step is to multiply the weight in kilograms by the amount ordered per kilogram. So we have our kilograms we just converted, and we multiply it by the amount ordered, which is this amount in our question, right? So it's 20 milligrams per kilogram. And we're able to cancel out kilograms here, and we're left with milligrams, right? So we do 34.54 divided by, multiplied by 20 milligrams. And what does that give you? 690.8 milligrams, right? And we want to know how many milligrams should the child take per dose. So if they have to take it every 8 hours, right? If you do 24 hours divided by 8, you get 3, right? So this means they're taking it 3 times a day. So you do 690.8 milligrams divided by 3, which is the number of days they're taking it. And that gives you 230.2, we're going to round that off, 27 milligrams, right? That's how many milligrams the child should take per dose, 230.27. Now, a doctor may also order pediatric medication for pediatric patients in a daily total to be divided in equal doses with the dosage strength already specified. So, for example, Ms. Smith is to take 250 milligrams a day divided into 4 equal doses. How many milligrams will be given per dose? So, all you do is divide the dose ordered by the number of times a day is to be taken. 250 milligrams per day divided by 4 doses per day gives you 62.5 milligrams per dose. A doctor may order medication for a pediatric patient in a single dose with the dosage strength already specified. For example, Mr. Jones is to take 20 milligrams daily. How many milligrams will he take in 5 days? So you multiply the amount taken in a dose times the number of days. So he's taking 20 milligrams a day, right? For 5 days. So 20 milligrams times 5 days gives you 100 milligrams. Another thing you would like to do is to understand pharmacy vocabulary, because it also helps you. By understanding pharmacy vocabulary, you're going to be able to understand how to go about solving your problems. It makes it easier to understand what's being asked in pharmaceutical word problems. It is a very necessary skill that you must acquire. So in order to be able to calculate medication doses, it is important to understand the vocabulary of pharmacy. So if you look at this prescription, you have amoxicillin, 250 milligram tablets. Now, the prescription says 2 tablets by mouth 3 times a day for 7 days, number 42. So from this prescription, you should be able to answer how many tablets are taken in a single dose, how many tablets the patient is taking as a daily dose, what's the frequency of the medication taken throughout the day, and how many milligrams the patient is receiving daily, and how many tablets is required to fulfill this prescription. And here's another prescription, amoxicillin oral suspension, 125 milligrams per 5 ml, sugar-free. The patient is taking 125 milligrams 3 times daily. The supply is 100 mLs. So from this prescription, you should see that for every 5 ml, the patient is getting 125 milligrams of the amoxicillin. And the supply is 100 ml. So in addition to carefully reading the prescription or doctor's orders, it is also important to understand how to read the medication label to determine what the pharmacy actually has in stock. So pediatric medication is frequently supplied in liquid form, while adult medication is frequently in tablet or capsule form. Supply is expressed as a ratio with the dosage amount per a commonly used quantity. So for example, 250 milligrams over 5 ml. The commonly used quantity is the 5 ml. And for us, it would be a teaspoon. 1 teaspoon is equivalent to 5 ml, right? So what does that mean? That means for every teaspoon, the patient is getting 250 milligrams of medication. Now there's also 100 milligrams per ml, 50 micrograms per 1 ml, 20 milligrams per tablet. That means that every time a patient is taking the tablet, they're getting 20 milligrams of medication. The same thing applies to 250 milligrams per capsule. And these are examples of prescription medication labels. And if you look over here to the left, upper left-hand corner, you have diflunisal tablets, 500 milligrams. So every time the patient takes 1 tablet, they're getting 500 milligrams of medication. For fluoxetine, 20 milligrams per 5 ml. Every time the patient takes 5 ml or a teaspoon of medication, they're getting 20 milligrams of medication of the fluoxetine. And the grisfulvin, microsize, so it's 125 milligrams per 5 ml. And the phentoin, 250 milligrams per 5 ml. And here we have the amoxicillin oral suspension, 200 milligrams per 5 ml.